Hello everyone. Today I will teach you a topic. That topic which is very common in GATE examination. So this class is going to be very important. And the topic is heat engine. In this class I will briefly explain the topic of heat engine, and then more importantly I will solve two numerical problems which have already come in GATE examination. So it is going to be very interesting. Therefore, stay with me till the end of the class, and don't forget to subscribe my channel to get more videos. We'll study heat engine. Heat engine. So today we'll study the heat engine. This heat engine is a very important topic. And if there is no heat engine, then there will be no car, motorcycles, bike, the bus, train, aeroplane, etc. Even this electricity, this is coming from the heat engine. Therefore we can say that there is a huge significance of heat engine, because due to the heat engine only we are getting this electricity. We are having our car, motorcycles, bike. We can move from one place to another place by train or plane, etc. Therefore heat engine is having a huge importance in our life. If there is no heat engine, the whole transportation system in the world would be hampered. Applications. Applications are as I said, all automobiles, all automobiles, such as car, bus, train, truck. These are the applications of heat engine. Due to the heat engine, these automobiles are working. So next will be aircraft, spacecraft. Spacecrafts, they are also using the heat engine. Due to the working of the heat engine only, this kind of crafts are working. Next we'll have ships, submarine, etc. are using heat engine. We can have steam turbine, gas turbine, nuclear turbine. Okay, that means in most of the power plants, heat engines are used to produce the electricity. The purpose of this heat engine is to produce power, to produce energy by using the heat. Okay, so heat engine is to produce power or energy. Clear? So basically heat engine is used to produce the power or energy, which is very important in our daily life. So basically this engine or this machine is a device which is producing power, energy or electricity from the source of heat. So here heat is the source. So heat is the source of the energy, and using the source heat, this machine is producing a power, energy or electricity. Okay, so in automobile the heat energy is converted into the mechanical work, and in case of power plants the heat energy is converted into the electricity. So we have understood the definition of heat engine, and at the same time we have also learned what are the example of heat engine. Okay, so if there is no heat engine, the whole earth will be without electricity, without any power. So now I will draw the a block diagram. So by making the block diagram, I will discuss how heat engine looks like. Okay, if we draw the block diagram, we are simply getting a heat engine is like this. So this is a block diagram of a heat engine. Okay, so this is our heat engine. Okay, so here we have source, and this is called sink. Okay, and this heat engine should have two reservoir. Okay, one is source reservoir, another is sink reservoir. Clear? So without these two reservoirs, our heat engine will not work. Okay, so the source will be the reservoir. The source will be the reservoir from where heat will be coming to the heat engine. Clear? And sink is a heat reservoir where heat will release. So this heat engine will receive heat from the source. Okay, so this is called source, and sink is a heat reservoir where the heat engine will release the heat. Okay, so here we will have a heat received, and here heat will be released. Clear? So this is the basic of heat engine. So this is a block diagram where we can understand that heat engine is receiving heat Q1 from the source, and this heat engine is releasing heat Q2 to the sink. Okay, so here we have suppose T1, here we have T2, and by this process heat engine will give work net. Heat engine will receive heat from the source, and it will release the heat to the sink, and as a result this heat engine will give the net work output. So this will be work output. Okay, so here we are finding that heat engine is taking heat from the source, and it is releasing heat to the sink. As a result, it will produce work. Okay, so this is the block diagram of a heat engine. Now if we need to find out the performance of this heat engine, we will find out efficiency of heat engine. So for this heat engine or block diagram, we can find out the efficiency of heat engine equals to W net by Q1. Clear? So the ratio of work done divided by the heat input will give the efficiency. Okay, so efficiency of heat engine is defined as the ratio of work net divided by heat addition. Clear? And this formula will become Q1 minus Q2 divided by Q1. Okay, so finally we are getting 1 minus Q2 by Q1. Okay, so this is the final expression of efficiency of a heat engine. So now this is a time to solve numericals, which are very important, because those two numericals I am going to solve have already come in GATE examination. Okay, so let us move to solve these two important numerical problems. So now I will solve two numerical problems which have come in the GATE examination of the year 1996. So the first numerical problem is: a solar energy based heat engine which receives 80 kilojoule of heat at 100 degree centigrade and rejects 70 kilojoule of heat to the ambient at 30 degree centigrade is to be designed. The thermal efficiency of the heat engine is, the options are 70%, 1.88%, 12.5% and interdeterminate. Numerical. So we are solving two numericals now which have came in GATE exam 1996. So in this problem, the efficiency is to be found out. Okay, so as we know that for any heat engine, the efficiency is depending on the heat addition and heat rejected. So in this question, heat addition is given, at the same time heat rejected is given. Okay, and this efficiency is to be found out here. Okay, so for any heat engine, so okay, cancel. So we have heat engine. So as per the question, we have the heat engine. Okay, we have here T1 equals to 100 degrees centigrade, T2 equals to 30 degrees centigrade, and Q1 equals to joule, 80 kilojoule, and Q2 equals to 70 kilojoule. So for this heat engine, Q1 is given as 80 kilojoule and Q2 is given 70 kilojoule. Okay, so heat received is equal to 80 kilojoule and heat rejected equal to 70 kilojoule. So as we know that the efficiency of that heat engine is depending on these two values. Okay, so as we know that the efficiency is given by heat engine equals to Q1 minus Q2 by Q1. Okay, so simply substitute the values of heat. Okay, so this is 80, this is 70, and this is 70. Okay, so if you calculate, you will find out the value equals to 12.5%. Okay, so this is the answer for the first problem. Okay, first problem. Problem number 2. For two cycles coupled in series, the topping cycle has an efficiency of 30% and the bottoming cycle has an efficiency of 20%. The overall combined cycle efficiency is, the options are 50%, 44%, 38%, and 55%. Here, in this question, it is given that there are two, heat engine. Okay, bottoming heat engine and a topping heat engine. In this question, it is asked to find out the combined efficiency. So this numerically is very tricky, because for this particular heat engine, two cycles are given. That means two heat engines are given, and by combining these two heat engine or two cycles, the combined efficiency is to be calculated. It is asked in this question, to calculate the overall or combined efficiency of this particular heat engine, which is having two different cycles. Okay, so let us start to solve this particular very tricky numerical. So in this block diagram, we'll have two heat engine. This one heat engine, okay. So this particular heat engine is having two heat engine or two heat cycles. So this is source, this is sink. Clear? So this is the first heat engine, this is the second heat engine. Okay, and this is heat exchanger. So we have first heat addition, heat rejected, here heat addition, here heat rejected. Okay, so here heat received is Q1, heat rejected is Q2, and whatever heat will be rejected, that heat will come to this second heat engine. Okay, therefore this heat received will be Q2. Clear? So for this particular second heat engine, the receiving heat will be equal to the heat which is rejected in the first heat engine. Clear? So whatever heat is rejected in the first heat engine, this particular heat rejected will be received by this second heat engine. Okay, that's why this is Q2, that heat is also Q2. So here we will have a final heat rejected equals to Q3. Okay, so here as per the block diagram, we have W, topping cycle. So this is the topping cycle, first heat engine, first cycle. This is the bottoming cycle. So we have W bottom. Okay, so here for this given heat engine we have two cycles. Okay, cycle 1, cycle 2. Okay, cycle 1, cycle 2, heat engine 1, heat engine 1, heat engine 2. Okay, so we have here two heat cycles for which efficiencies are given. Okay, so considering the first heat engine, which is having the first heat cycle, its efficiency is given 30%. Clear? And for this second heat engine, the efficiency is given as 20%. Clear? So for this particular heat engine, we are having two cycles. For these two cycles, efficiencies are given. For the first heat cycle, the efficiency is 30%, and for the second heat cycle, this cycle, the efficiency is 20%. Clear? And now it is asked to calculate the overall efficiency, combined efficiency. Okay, combined efficiency. Clear? And to proceed ahead or to find out the combined efficiency, we need to consider the first cycle and second cycle. Okay, so considering the first heat cycle, we are having this efficiency equal to, from this block diagram we can find out Q1 minus Q2 divided by Q1. Okay, and for this first heat engine or first heat cycle, we are having heat addition equals to Q1 and heat rejection equals to Q2. So taking into consideration these two heat amount, we can have a efficiency formula where the first efficiency is given by Q1 minus Q2 divided by Q1. Okay, so it will become 1 minus Q2 by Q1. Clear? And which is having 30%. Okay, so we are having this 1 minus Q2 by Q1 equals to 0.03. Clear? So considering the first heat cycle, we are having the efficiency equals to 1 minus Q2 by Q1 equals to 0.03. Okay, so using this equation we can simply understand Q2 or Q1 is having value of 0.70. Clear? Because 1 minus Q2 by Q1 equals to 0.30. Okay, that means this value is having particular value of 0.70. Q2 by Q1 will become 0.70. Okay, so this is our first equation. So for the first heat cycle, we have found out the Q2 by Q1 equals to 0.70. In a similar way, we'll calculate for this a second heat engine. Clear? And for this particular second heat cycle, the efficiency is given 20%. Okay, so as per the expression of efficiency of any heat engine, we have the formula for the second one. So for the second one, the efficiency will become Q2 minus Q1 by Q2. Okay, so considering this second heat engine, we are having heat addition equals to Q2 and heat rejected equals to Q3. Okay, so considering these two heat values, we can find out the efficiency. So here the efficiency will become heat Q2 minus Q3 divided by Q2. Okay, and this is equal to 20% as the given problem. Okay, so now if we simplify, it will become 1 minus Q3 by Q2. this equals to 0.0302. Okay, so now the efficiency for the second heat engine will become 1 minus Q3 by Q2 equals to 0.20. So from this expression we'll find out Q3 minus Q2 equals to 1 minus 0.20, that means 0.80. So we have got two equations considering the efficiencies. Okay, so this is our equation number 2. Using this equation number 1, we can get Q1 equals to Q2 divided by 0.70, and from the equation 2 we can find out Q3 equals to 0.80 into Q2. Okay, so these are the so finally we have received Q1 equals to Q2 by 0.70 and Q3 equals to 0.80 into Q2. So now using these two values, okay, we will find out the final and combined efficiency of the heat engine. So let me solve the numerical in the same page so that it is easy for understanding. Okay, the overall efficiency or combined efficiency will become cancel. So now the efficiency of heat engine will be Wt plus Wb divided by Q1. Clear? So in the simple way we are having the work output as the summation of these two work net, okay, and heat addition equals to Q1. So considering the whole heat engine, we are having the work output as summation of Wt and Wb, okay, and heat addition here is Q1. So we can simply find out the efficiency will be given by Wt plus Wb by Q1, okay, and after simplification it will become Q1 minus Q3 divided by Q1. So now the combined efficiency will become Q1 minus Q3 divided by Q1. Okay, so we can simply replace the value of Q1 and Q3 from the earlier equations. Okay, so if we replace the values of Q1 using this equation and Q3 using this equation, we can find out Q2 by 0.70 minus 0.80 Q2 divided by Q2 by 70. Okay, so after simplification this value will become 44%. Okay, so by replacing the value of Q1, Q3 in the overall efficiency, we can find out the final efficiency equals to 44%. So as the summary of this my particular class, we have learned what is heat engine, okay, what are the applications of heat engine, how heat engines are applied to have different practical machines, and finally the most important part of this class was solving the numericals. So I hope that you have understood the concept of heat engine. At the same time you have also understood how to solve some numerical problems. Okay, so that's all for today. Thank you so much. See you in the next class.